Are you ready? Today I am going to dive right into Wolfram Physics. If you've never heard of Stephen Wolfram or his team's project to find the fundamental theory of physics, don't worry. Think of it like this. I'm going to dive right into the fundamental structure of the universe. And, well, you might not believe that the words simple and physics can go together, but I'm going to keep it simple. This deep dive is going to raise more questions than answers, but that's okay. I'll be looking into those questions and looking for answers in future episodes. So, without further ado, here's the universe. Well, I told you I was going to keep it simple, didn't I? Actually, this isn't the universe so much as one possible universe. And it's that universe right back at the beginning of time, before it explodes into, well, we'll soon see what it explodes into. This universe consists of 3 nodes connected by 2 edges. The nodes are just points. There's one node on the left, and there are 2 on the right. Up here, down here. The edges are just lines between the nodes. One edge goes from the node on the left to the node that's upper right here, and the other edge goes from the node on the left to the node that's at the lower right side here. Each edge has a direction, which is indicated by the arrowhead. A set of nodes and edges like this is called a graph. It's a confusing term. When I talk about a graph, I'm not talking about a plot of y against x. Rather, when I'm talking about a graph, I'm talking about a set of nodes and edges just like this. And that's it. That's all there is to our universe. Just 3 nodes and 2 edges. Simple. This universe, however, doesn't stay simple for long. There's one last concept that I want to bring in here. I've talked about nodes, edges and graphs. Now I want to talk about rules. Rules are like the laws of physics. They determine how the universe changes over time. Actually, let me restate that. If Stephen Wolfram is right, then rules aren't just like the laws of physics. Rules are the laws of physics. So let's apply a simple rule to our universe. The rule has 2 steps. Step 1 is to find edges that match the rule. In the rule that I'm going to apply, that means finding 2 edges that come from the same node. In the case of our simple universe, matching the edges is easy. There are only 2 edges, and they do come from the same node. I'll highlight them in blue to show that we found our match. Step 2 is to evolve the matched edges according to the rule. In the rule that I'm going to apply, that means deleting one of the 2 edges, creating a new node, and creating a new edge from each of the 3 existing nodes to the new node. Okay, let me run through that more slowly. First, we need to delete one of the 2 edges. I've chosen the lower of the 2 matched edges, and I've highlighted it in red to indicate that it's about to be deleted. Nothing's going to happen to the other matched edge, so I've turned it white again. Next, we need to create a new node. Now, I could have put it anywhere, but for now I've placed it here, right at the centre of the 3 existing nodes. Finally, we need to create a new edge from each of the 3 existing nodes to the new node. I've highlighted these new edges in green. So this is one, this is the second, and this is the third. As ever with edges, their direction matters. They're from the existing nodes to the new node. So the green arrows all point towards the new node in the middle there. So here's what the graph looks like after the rule has been applied. I've deleted the red edge and I've turned the green edges white. So we now have 4 nodes and 4 edges. Still pretty simple. It really doesn't matter where in space I position the nodes and the edges. Why not? Because these nodes and edges aren't in space. These nodes and edges are space. I'll say more about this in a future post. Prepare for your mind to be blown. For now, I'm going to reposition the nodes so that they're more spread out, which will just make the graph easier on the eyes. And that's it. Now you know everything you need to know to work out how this universe evolves. 3 nodes, 2 edges, 1 rule. So let's apply the rule again. Step 1, remember, is to find 2 edges that come from the same node. There's still only 1 pair of edges in our universe that match these criteria, the ones highlighted in blue. Step 2 is, again, to delete one of the 2 matched edges. I've highlighted it in red, the one that I've chosen to delete, and then create a new node and 3 new edges. Again, I've highlighted them in green. Those new edges running from the 3 matched nodes to the new node. So that leaves the universe looking like this. Again, I'm just going to reposition the nodes just so that they're spread out more. And so we've applied the rule twice now. If we applied the rule over and over, something curious happens. So what's happening here is that I'm applying the rule again and again. Exactly the same as I showed you the first time. I'm just choosing the edges to match. Sometimes there are multiple possible matches that I can choose. And I'm deleting one of those edges, creating a new node in the middle of the 3 existing nodes and creating 3 new edges in exactly the same way as I've showed you already. So our simple universe is starting to become complex. The more times we apply the rule, the more complex the universe becomes. This seems strange. We'll see that after only a couple of 100 iterations, the universe will already have structure, clusters of tightly connected nodes that are only loosely connected with each other. How can such a complex universe arise from such a simple rule? And here's the crucial question. Might a universe as complex as our own arise from a similarly simple rule? As I say, that's more questions than answers. Make sure you're subscribed to The Last Theory to join me in my exploration of Wolfram Physics, and I'm hoping that in future episodes I'll be able to answer some of those questions. Thanks for listening to The Last Theory. Join me for fresh insights into Wolfram Physics every other week. Subscribe to the free newsletter, podcast or YouTube channel at lasttheory.com. After all, this might be the most fundamental scientific breakthrough of our time.